Let's talk about how to solve these particular integrals. These are called the Fresnel integrals. They show up in physics and areas like optics, where they describe particles that continue to oscillate forever, but the wavelength continues to decrease. And the cool thing is that we're gonna get these two solutions for the price of one. Now, before we begin, I want you to trust me on two things. One, that this is the Gaussian integral for any value alpha will equal to the square root of pi over alpha, and also that this is the Euler formula, e to the ix is equal to cosine x plus I sine x. And now we go ahead and rewrite our input as negative x squared. So we have the cosine with the negative x squared and the sine with the negative x squared. On the left side, we kind of just clean that up to make it look a little nicer. And on the right side, we recognize that cosine is an even function and that sine is an odd function. Now, if we take the integral of both sides, you'll see that the right side are the Fresnel integrals, and on the left-hand side is a simple integral we should solve. And hey, that looks very similar to the Gaussian integral. So in this case, our alpha is negative I. I believe I misspoke because the alpha is really just I, since the negative x squared is part of the Gaussian integral. So really we just have an I underneath the pi. Now let's just go ahead and rewrite this as I to the negative 1/2 times the square root of pi. So we really got to figure out what I to the negative 1/2 is. In the complex plane, I is situated on the imaginary axis. And since that creates an angle of pi over 2, we can go ahead and rewrite I as e to the I pi over 2. But we want to take this to the power of negative 1/2. So we're going to go ahead and do that and just simply implement some properties of exponents. And on the left-hand side, we have I to the negative 1/2. And on the right-hand side, we get e to the I negative pi over 4. And using Euler's formula, we get cosine of pi over 4 minus I sine of pi over 4. So now let's just go ahead and multiply this by root pi. So I'm just over here finding the values for cosine and sine of pi over 4, but I do talk about this in my book of marvelous integrals, and I highly suggest you get yourself a copy. Looks like I missed the root pi here in the front. This is our answer, but I'm gonna rewrite it so everything is underneath the square root. And keep in mind that this whole time we were actually finding these particular integrals. So that tells us that both Fresnel integrals are equal to the square root of pi over 8. That's pretty cool.